Right? So what I mean by people don't pay attention to the context of this question is this. What kind of motion is going on in this question? Uniform or accelerated? If I throw something up in the air, as soon as it leaves my hand, it's doing what? It's negatively accelerating. This is an acceleration problem. But what I see often happen is people use v equals d over t to try to solve it. But you can't do that. Okay? The velocity is changing in this question. Okay? You don't know what the average velocity is for this, so you have to do it as an acceleration question. And this is where people go wrong. The context of the question tells you what the acceleration is, but people miss that. Where is this object right now? On Earth. It doesn't outright say that, but we do have to assume that since it doesn't outright say it's anywhere but Earth. Okay? So what we have to do is we have to say that first off, the acceleration is 9.81 meters per second squared down. Question doesn't give us that number, but the context of the question tells us it applies. Okay? Then we have to also say that the initial velocity is 17.5 meters per second up. And the time is 1.5 seconds. We're looking for how fast it's going after 1.5 seconds. Okay, so it is an acceleration problem, and it's one that uses the formula from last year in Science 10. It's going to use this formula, A equals VF minus VI over T. So what I need to do here is solve for VF. Well, I'm going to solve for VF by multiplying both sides by T and then adding VI to both sides. So that'll solve for VF. So all I have to do then is go 17.5 plus a T times A, which is going to be 1.5 times, and this is crucial, negative 9.81. If I don't make that negative, then what it says is once the marker, or once the rock leaves my hand, the ball, whatever it's a ball, okay, once the ball leaves my hand, I'm going to go faster. Last time I checked, that violates that old axiom of what goes up must come down. Okay, if I throw a ball up in the air and after it leaves my hand, it continues to accelerate upwards, everything we know about physics is out the window. Okay? So, I'm not saying that to kind of make fun of anybody, but I'm saying when you get your answer, make sure it makes sense within the context of the question. Because I had a number of answers on this quiz this morning that were greater than 17.5. Okay? And it wasn't that people are dumb, they're not. They just didn't think about it. They did the problem without thinking about what direction that acceleration was, got their answer, and went, woohoo, check that box, I'm done. Okay? Without going, wait a minute, how can that object be going faster if I threw it up in the air? It has to be slowing down. Gravity's pulling it back. You can always use the context of the question to give you an idea of whether or not you've done it right. Okay? But it involves you having to read the question carefully, kind of go, okay, imagine myself throwing something up in the air, or I wouldn't have been angry if I'd have seen anybody doing this at their desk. Throwing something up in the air, just kind of watching it. Okay? There's nothing wrong with that. In fact, I would have been really impressed if somebody had done it. Okay? All right. So I've got those numbers there plugged in. Okay? So what we have here is 17.5 plus 1.5 times negative 9.81. And that's going to give us to two significant figures, 2.8 meters per second up. Then it will be wrong.
Really?
Yes, see, because the question says up. Up is the vector, so your answer has to have up or down as the vector. Yeah. I know that seems really picky. And it is. And I make no apologies for that. It is picky. Okay? But it's also physics. We have to be picky. All right. If it had said how fast is the ball going, then I'd have been okay with not up, but it specifically says what is the velocity of the ball. It says I have to have a vector on it. Okay, questions on number 1. Okay. All right, for question number 2, so we have a velocity versus time graph. And really, this question is testing two things. First off, do you remember how to calculate displacement from a velocity versus time graph? And the second thing it's asking is, do you remember that average velocity is total displacement divided by total time? Okay, there's 6 marks in this question. 5 of them are for calculating the displacement. 1 of them is for doing a v equals d over t calculation. Okay, and that's it. So here's what we're looking at. I need to calculate the area between the line and the x-axis all the way along this graph. So there's this triangle here. Okay, there's this rectangle here. There's this triangle here. There's this triangle. And there's this rectangle. Okay, those are the shapes I've got to get. Now, a lot of people don't like the answer they get for this question. How many people didn't like the answer they got for this question? Yeah. And I can totally see why. But if you look at the graph, does it make sense? Okay, well, let's have a look at it. So, in this part here, the object is accelerating in a negative direction. Okay, it's going faster in a negative direction. Okay, I can calculate the area here. It's -3 times 3, so base times height, -9 divided by 2. Okay, so this is -4.5 meters. All right, this rectangle here is -3 times 2, so it's -6 meters. And then this one here is -3 times 1 over 2, -1.5. So in total, there's 12 meters in the negatives for this graph. All right, now I look over here where the object has started into the positives. Now it's moving forwards. So I've got this triangle here that's 2 on the base and 6 high. Okay, so 2 times 6 is 12, divided by 2 is 6 meters. And then I've got this one that's 6 times 1, 6 meters. So I've got 12 positives and 12 negatives. What's my total displacement? 0. Which means my average velocity is also 0. Okay? Now, does the context of the question make that answer more acceptable to you? Okay? If we look at it that way, if we see what's going on rather than just try to plug numbers in, we get a much better sense of what's happening in the question and can feel better about our answer, or maybe not better if it's wrong. Okay? But at least then, when you get 0 for this, you can look at it and go, oh yeah, that should totally be 0. They went just as far backwards as they went forwards. That makes total sense. They, instead of just, oh, I got to plug this number, plug that number, plug this number, and then we just don't see the importance of that. Okay? Physics isn't about calculations. That's math. Physics is about understanding and seeing what's happening. Okay? Math is. All right.
Yeah,